Okay, we're going to look at finding the axis of symmetry, which we'll kind of refer to as the AoS, the vertex. I put axis, but we're going to look for like intercepts of the axis and from standard form. So I've kind of given it away. We're already in the standard form. And the reason we're doing this from the standard form is because this information is not visually easy to pull out from the standard form. We have to usually manipulate the equation. And when I say manipulate the equation, usually what that means is taking the standard form and trying to put it into factored form. That will give us like our x-axis, or sorry, our x-intercepts. And then from the standard form, we can move it to the vertex form, which will give us essentially the vertex and the axis of symmetry. Okay, so what we're about to do is kind of go in this roundabout way to the vertex. There is a faster way to the vertex, but the reason we're doing it is because we're going to figure out what the x-intercepts are along the way, so getting into factor form will be helpful. So there's quite a few steps here. To go from standard to factor form, we factor this. This one is a y is equal to negative x squared minus 2x plus 3. Okay, we'll use a little decomposition here. We need two values that multiply to whatever a times c is, and in this case that's negative 3. And those same two values need to sum to the b value, which in this case is negative 2. 3 is a prime, and that's a negative 2, so this scenario, these two values are 1 and negative 3. So what we're going to do next is we're going to decompose the center term, or the b term, from the standard form. I should have written that in. This is the b, this is the c, and this is the a. The a in this case is negative 1. We're going to decompose here, so when we decompose that, you can write it as negative 3x plus x plus 3. If we do a little common factoring by groups, so we group the first two together and we find common factors, I can factor out, and I'm going to factor out negative x in this case, just because these are both negative. So I'm going to go negative x and negative x. And from here, I can't factor out anything, so we factor out, think of it as the term of 1. The common factor comes to the outside, so we get negative x. And then in our set of brackets, negative x squared divide negative x is positive x. Negative 3x divide negative x is positive 3. When we factor out 1, 1 becomes our lonesome common factor, and we're left with x plus 3, which is great for our decomposition because we bring these two brackets over and we get x plus 3 as one scenario, and then in the other one we have whatever's left over, which is negative x plus 1. Great. We are currently in factored form. This form makes it easier to find x-intercepts. One of the first questions, which I kind of blew right by, is I put axis, but really we wanted intercepts. This is the y-intercept. I don't have to do any searching. The c value is the y-intercept. So we're going to try to collate a whole bunch of this information. And a y-intercept is when x is 0, so we know that right away. There's our y-intercept. Factor form helps us find x-intercepts. In order to find those x-intercepts, we need to have when y is equal to 0. So in this case, we have y here. We're going to say, what is this when y equals 0? So we sub 0 in here. It's equal to x plus 3 and negative x plus 1, which means one of these brackets must be 0 because they multiply to 0. So we're going to just jump over here and create two equations. 0 is equal to x plus 3, and 0 is equal to negative x plus 1. When I go to solve that, 3 goes to the other side, and we get x negative 3. Here, it becomes negative 1 is equal to negative x, but we have to divide by negative 1, so we get x is equal to 1. These are your two x-intercepts. So one of them is negative 3, 0. The other one is 1 and 0. So there's some good information. Quite a bit. We've crammed it all into one page here. Let's get another page going because that only gives us some of the information. So far we've got the x-intercepts. So we'll kind of put it together here. Intercepts, which we said were negative 3, 0. And 1 and 0, so there were two roots. We didn't use the discriminant, but we figured it out through factoring. The y, I'm just going to put brackets here, intercept, happens to be 0 and 3. The standard form of our equation, y equals negative x squared negative 2 plus 3. This is our standard form. I'm kind of just collating the info we have so far. The factored form, which we solved, or I shouldn't say we solved, but we got to, was x plus 3 negative x minus 1, I believe. Negative x plus 1, sorry. Plus 1. Okay. What we need to find is something called the axis of symmetry. I'm going to call it the AoS. The axis of symmetry, okay, can be solved through an equation. Think of the equation as the first x-intercept, so I'll call it x subscript 1 plus x subscript 2 divided by 2. And what that is we're finding the average, we're finding the average between the two x-intercepts. And the reason we're finding the average is because we're trying to find the middle, or the x value of the vertex. So I'm going to kind of quickly give you a sketch of what that means. We already know our two x-intercepts. One was at negative 3 and one was at 1. So if I were to quickly draw a rough sketch of this parabola, and actually I've done that wrong, because we know this parabola opens downwards because the a value is negative. That's really important. It goes like this. When we take the average, we find the middle. And the middle of a quadratic is the axis of symmetry, an invisible vertical line that cuts this symmetrically through the middle. Okay? So first x-intercept is negative 3. So we substitute negative 3 plus the other x-intercept was positive 1. We divide these by 2. This gives us negative 2 divided by 2, which gives us negative 1. That means the axis of symmetry, I'm going to say the AoS, is x, it's an equation, is equal to negative 1. And when it's an equation, x equals negative 1, that means it is an actual line. This is actually a vertical line. So what I'm going to do, put in the equation we had here. It was negative x squared minus 2x plus 3. Okay, not to give away all the information we have. But here's our parabola. Like we said, it faced downwards, and we knew we had two x-intercepts, one at negative 3 and one at 1. But we know that x is equal to negative 1. You'll notice that cuts right through the middle of this equation. And I'm going to make it a little bit of a dotted line. Just to see that, think of it as like an imaginary vertical line that's cutting this through the middle. What's convenient about the axis of symmetry is this is also the x value of the vertex. The x value of the vertex is also negative 1. So if we were to write the vertex as a coordinate, and the x value, and then the y value, that little v just stands for vertex, we would have negative 1 and something. We just don't know what the y is. Because we have a coordinate, I can now take this coordinate and I can substitute it in for x in the standard form or in the factored form, and that will tell me the y value of the vertex. And we alluded to this not in this video, but a while back, about overviews, and this is like a process of going from factored to vertex form. We have our vertex form, or sorry, we have our factored form. Once we have our vertex, we can write the vertex form. We are one number short of writing the vertex form technically. So what I'm going to do is I'm going to quickly jump to the next page here, just because I don't think I have enough room to do it on this page. Do a real quick recap once again. Y is equal to negative x squared minus 2x plus 3 is the standard form. I want to show you both forms because I don't remember this. Plus 3. Negative x plus 1. I want to write these here because what I'm going to show you is that we're going to plug in that axis of symmetry, or the x value of the vertex, into both of these forms, and we're going to end up with the exact same value. So in this case, y is equal to negative, and if you recall the axis of symmetry, write it in green here, so just was equal to negative 1, okay? So we're going to substitute that in for x. Negative 1 squared. A little tricky in this scenario here. We have to really be aware of what our order of operations is. And in this one here, so I'm going to simultaneously do them. We get -1 plus 3. And again, -1. That one's a bit tricky again. Okay, so let's focus on the standard form. Y is equal to -1 squared is 1. And think of it again times -1. So it gives us -1 again. -1 times 2 is +2 plus 3. We'll just keep going here. This is going to be 4. Here we get y is equal to 2 times -1 times 1 is 1, so 2 again, and y is equal to 4 again. So in both scenarios we got 4, which means for our vertex we have -1 and 4. This was the x value of the vertex, this is the y value of the vertex, okay? So we have our vertex here. We'll jump over and take a look at it. Yeah, -1 and 4. We have our x-intercepts. That's great. We knew the y-intercept from the beginning. That's perfect. What we didn't do is we can also write this in vertex form. If you remember, the vertex form is y is equal to a x minus h squared plus k. We know the a value. The a value, and now technically I'd have to factor this by -1 to bring the a here, but the a value in standard form, it's easier to see, is -1. So I'm going to write that in, a value being -1. The h value is the same as the x value of the vertex. This is what h is for vertex form, and this is what k is. So it's -1, so it's x subtract -1. So always keep in mind when we got those negatives, it can get a little tricky because we're flipping signs around. And the k value happens to be whatever the y value of the vertex is, and in this case that happens to be 4. I should have wrote this in blue since I was writing h's as blue, just to be a little more consistent. That means the vertex form of this quadratic is y is equal to -1 x plus 1 squared plus 4. If we write our 3 versions in here, here is the original one. Our factor form, other one, we said is y equals x plus 3, just to verify, -x plus 1. Okay, you'll see it overlaps. Technically, and I know I've showed you this before where the a values are the same, this one looks like the a value is only +1, but I can common factor from here. If I had common factored that value, I would actually get a -1 on the outside, and I'd have x plus 3. The first bracket is unchanged. The second bracket I common factored out -1 would be x minus 1. Same equation again. Oops, not 10, 1. And finally, that vertex form that we just found, y is equal to -1. We said it was x plus 1 squared plus 4. And you notice it continuously overlaps again and again and again. The last few things we do got to talk about is the y value of the vertex. This is known as an optimal value. Optimal value. Also known as the max or min. Okay. And what's important about that is it just completely depends on whether this opens up or down. Because it opens downwards, this is the max value. In other words, the highest it goes. If it opens upwards, it would be the min value. So in this case, we have a maximum because it opens downwards. Okay. If it opened the other way, we'd have a minimum value. Okay. So we found a lot there. We found all the y-intercepts, the x-intercepts, the vertex. Missing something. The axis of symmetry, the optimal value, and the maximum value. So a lot of information passed along in that question there.